Surfing on the highway, cruising so fast, I want them to fly. Fun, think about fun. You know what it is. This, my friend is by my right. Hey, I got this, you got this. Now you know it. Kicking in the front seat, sitting in the back seat. Gotta make my mind up. Which seat can I take? It's Friday, Friday. Gotta get down on Friday. Everybody's looking forward to the weekend. Weekend, Friday, Friday. Getting down on Friday. Everybody's looking forward to the weekend. Partying, 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 partying. Fun, 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 fun. Looking forward to the weekend. Your day was Thursday, Thursday. Today it's Friday, Friday. We so excited. We so excited. We gonna have a ball today. Tomorrow is Saturday and Sunday comes afterwards. I don't want this weekend to end.
The black, so chillin' in the front side, in the backseat, I'm driving, cruising, fast lane, switching lanes, with a car by my side. Come on, somebody, it's a school bus in front of me. Next tick tock, on the street. My time is Friday, it's a weekend. We gonna have fun. Come on, y'all.
Friday, Friday, gotta get down on Friday. Everybody's looking forward to the weekend. Weekend, Friday, Friday, getting down on Friday. Everybody's looking forward to the weekend. Partying, 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 partying. Fun, 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 fun. Looking forward to the weekend. Friday, Friday, gotta get down on Friday. Everybody's looking forward to the weekend. Weekend, Friday, Friday, getting down on Friday. Everybody's looking forward to the weekend. Partying, 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 partying. Fun, 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 fun. Looking forward to the weekend.
Good morning, everybody. That was the greatest song of all time, if you've never heard it before. Friday by Rebecca Black. All right, almost everybody's here. All right, let me show you a couple things. So we are remote through January 8th, so we'll be back on January 11th. At least that's the preliminary plan. That's as soon as we'll be back. If the I suspect that if the case count and hospitalization rates continue to increase, that we may even be longer than that, even much longer than that. So we'll just have to wait and see how things go. So stay socially distant and stay safe. Safest thing for us to do is be around as few people as possible. All right, let's see. Okay, let me show you what we got going on in the Unit 5 folder. I'm going to reorganize these, so actually the newest ones will be at the top. I'm going to reorganize it like visually so it's in the opposite direction. In the current week, so what we've done this week is look at ionic compounds and how they go together, how they're named as basic ionic compounds with a metal and a non-metal, and then things about polyatomic ions and transition metals. I gave you this compound writing practice and asked you to work on it for today. I'm going to go over these with you now, and then there's another one here that says naming review. This is naming review 4, and I put this in the plan for the week. These are additional practice problems. You need to be able to write formulas for and name ionic compounds as quickly and as efficiently as you can, so that anytime you see the name of a chemical, you can figure out what formula it is. Because pretty much everything dealing with calculations and writing chemical reactions has everything to do with looking at and understanding the formula. But in prose, like in writing, we write the name of the compound. It's sort of not correct to put the compound as the chemical formula. It's really only correct to put the compound as its like name. So if we're talking about silver chloride, we write out the words silver chloride. We don't write like AgCl. It's just sort of not correct to do that. Not to say that AgCl is not the formula for silver chloride, but in writing, we always write the name and not the formula itself. All right. I noticed that like my video is not so good when I'm like monitoring it, and I think that my sound's a little bit behind. If you could put in the chat if it's not looking good, that would be great, because it's not looking good here. In other words, like I log in as myself with another computer to be able to watch it, so that I make sure I got the right screen up, and it looks pretty crappy. Anyway, if it looks crappy, write in the chat it looks crappy. If it looks good, or if I cut out, just put that in the chat. That way I'll know. Or you can turn your mic on and just be like, Mr. Flint, we don't understand what you're saying or can't see anything. I don't know. Okay, let me go to the open board. Here we go. Okay, so these are the problems that are from the, let's see, what's it called? The ones I put in the end of the folder from yesterday, compound writing practice, a mix of all types of ionic compounds. So whenever you're dealing with writing formulas and names for compounds, and you happen to know that it's got a transition metal, or it's a compound that has a polyatomic ion. Hold on a second. Let me try to leave and come back in and see if that helps from this other one. But a lot of times, you know, you don't necessarily know if it's ionic, if it's covalent, if there are polyatomic ions, if it has something to do with transition metals or something like that. So there are some clues that you can get from the names, and some clues you can get from looking at the formula itself to determine like what kind of compound it happens to be. All right. So let me tell you what I mean about those kind of clues. In this first one, it says copper 2 nitrate. Okay, so first off, there's this copper 2 and the 2's in parentheses. So that means that this copper 2 must be a transition, or copper must be a transition metal. And it turns out you don't even have to look up what the charge is, because whatever this number in parentheses is happens to be the charge. So I know that if it's copper 2 nitrate, it has to be Cu2+. The 2 in parentheses just simply means that it's copper 2. The nitrate, so this has the NITR, niter. And if you go to the periodic table, you'll be like, well, that looks like nitrogen, except it turns out it's not just nitrogen, because nitrogen as an ion is nitride. All anions as single elements always end with "ide." So it's not copper 2 with a nitrogen. Instead, nitrate must be some other kind of ion. And you can refer to an ion chart. So this chart here is that charge of anions, and you'll see nitrate. So what I'm talking about is if it were nitride, nitride is N3-, because if it's just the element nitrogen, it would always end with "ide" as an anion. So there's nitride, which is N3-, nitrate and nitrite, those must be some kind of polyatomic ion. And it turns out nitrate is NO3-. So this nitrate came from NO3 1-. This is a transition metal, and that's a polyatomic anion. So this is a transition metal, and the NO3 is a polyatomic anion. Remember, we call it polyatomic because it's made up of 2 or more individual atoms. Polyatomic anion. Sorry, my pen's a little bit behind. If I shut shut Safari sometimes. Shut Safari and Mail. There we go. So we got to make a compound with copper and the nitrate anion. Copper has a charge of 2, nitrate has a charge of 1. So we're going to need 2 nitrates to go with every copper. So it's going to be Cu, and then in parentheses, NO3, oops, got to back that up, NO3 too. Or you can do what we call the cross-down method. So whatever the charge for the copper is, that's how many nitrates you need. Whatever the charge for the nitrate is, that's how many coppers you need. So that's the correct formula for copper 2 nitrate. Sodium hydroxide. Sodium is just a plain old metal. On the periodic table, it's in group 1, so that it has a charge of 1 plus, Na1 plus. If it were a transition metal, there'd be a parenthesis number like with the iron 3 and copper 2. So Na plus, and then hydroxide. Well, hydro sounds like hydrogen, except hydrogen doesn't form anions. Instead, hydroxide is one of these polyatomic anions. Hydroxide right here is OH minus. So it's Na plus and OH minus. Sodium with the hydroxide is just NaOH. And although hydroxide is a polyatomic ion, it only goes in a parenthesis whenever there are 2 or more of it. So because there's only 1 hydroxide, you don't have to put it in parentheses. Sodium hydroxide is a strong base. It can be used as a drain cleaner, sodium hydroxide in solution. Okay, lithium oxide. So lithium, it turns out, is just a group 1 element, so it has a charge of 1, Li 1 plus, and oxide, this ends with ide. So if it ends with ide, it must just be a simple anion with oxygen. The oxide anion, oxygen's in group 16 of the periodic table, so it has a charge of 2 minus. So Li and then O with a charge of 2 minus. You need 2 lithiums with every oxygen in order for the compound to be neutral. So, or you can do the cross-down method. Whatever the charge for the oxygen is, that's how many lithiums you need. Whatever the charge for lithium is, that's how many oxygens you need. So Li2O is what you got to do. Aluminum sulfide. So aluminum is right here on the periodic table. It's like in the first part of the P section of the table, has a charge of 3 plus. So aluminum is 3 plus, and this ends with ide. And if it ends with ide, it must be a simple anion. So sulfide comes from sulfur. There are other things that start with sulf, like sulfate and sulfite, but because it's sulfide, that's just the regular anion. So it's S2 minus. And in order for this to be neutral, you're going to have a charge of 6 for the total for the aluminums and 6 for the sulfurs. Or with the cross-down method, whatever the charge for the sulfurs is how many aluminums you need. Whatever the charge for the aluminum is, that's how many sulfurs you need. So Al2, S3. Okay, then iron 3 phosphide. So iron 3, that's easy. Iron symbol is Fe, and the charge is 3 plus, because whatever is in the parenthesis, that's got to be the charge. And phosphide, this also ends with ide, so that must come from phosphorus, just phosphorus. You'll see there's phosphate and phosphite as polyatomic ions, but phosphide is just phosphorus with a charge of 3 minus. So phosphorus with a charge of 3 minus. Because each of them has a charge of 3, you only need 1 of each. So FeP is all you need. You wouldn't write Fe3P3 because those can each be reduced to just 1. So FeP, that should be good. Okay, and then let's see. Oh, did I miss number 6? There's number 6 on there. Oh yeah, it's down here. Okay, I gotta write it up here. It's kind of weird. My tablet, if I write too far down, it does this funky thing. I'll show you. See what it does? It does that craziness. So nickel 3 sulfate. Nickel 3 is Ni3 plus, and sulfate is not sulfur by itself, but sulfate must be one of these polyatomic anions. Sulfate is SO4 2 minus. So we got SO4 2 minus. So you got Nickel with a charge of 3, sulfate with a charge of 2. You're going to need 2 nickels, and then 3 sulfates. SO4, 3. So nickel 3 sulfate. That's how that one goes. All right, and then 7, 8, 9, 10, 11. So potassium oxide. Potassium is in group 1 of the periodic table. It's K1 plus. Oxide is just oxygen, and oxygen has a charge of 2 minus. So we have potassium with a charge of 1, oxygen with a charge of 2 minus. You're going to need 2 potassiums for every 1 oxygen, K2O. Okay, then hydrogen chloride. Hydrogen is in the first group of the periodic table. It can act as a cation. And then chloride, this ends with ide again, so it's from chlorine. And chlorine is a halogen, so it has a charge of 1 minus. It's just HCl. In water, this is hydrochloric acid, but as a gas, it's hydrogen chloride gas. And it's actually sort of covalent. There's some things that are kind of covalent, kind of ionic. We name this gas hydrogen chloride. So although it can behave as individual gas molecules, as a Lewis structure, it's ionic and named as an ionic compound. All right, calcium hydroxide. Calcium on the periodic table is in the second group, so it's Ca2 plus. And hydroxide. Now, hydroxide is kind of a tricky one because you'll be like, well, this ends with ide, and ide seems like it's just an individual atom. And you might be like, well, maybe it's like hydrogen or something, except hydrogen is always a metal, so it's not like hydrogen changes to hydroxide. And the other thing is, this hydroxide has like hydra, which is like hydrogen, and it also has ox, which is like oxygen. So if hydrogen was going to be an anion, it'd just be like hydrogide or something, except that doesn't exist, so I don't even know how to say it because it's not even a thing. But hydroxide is something with hydrogen and oxygen. And what makes it kind of tricky to find on the table is the table of anions is that hydroxide is always OH. We don't write HO, we write OH. There's a reason why it goes O and then H. But hydroxide is OH minus. So the hydroxide is OH minus. Because calcium has a charge of 2, we're going to need 2 hydroxides. Hydroxide has a charge of 1, so we only need 1 calcium. But because hydroxide is a polyatomic anion, it's got to go inside a parenthesis. And then copper 2 oxide. Copper 2 is Cu2 plus. I'm not hydroxide, iodide. And iodide comes from iodine. And iodine or iodine has a charge of 1 minus. So we got copper 2 with the iodine. It's Cui2. And silver bromide. So silver is a funny one because silver is a transition metal. But as a transition metal, there's only one oxidation state or one ion charge possibility, and it's 1 plus. So although silver is a transition metal, it doesn't get a Roman numeral. It can only have a charge of 1 plus. And then bromine makes bromide, and bromine is a halogen, so it's Ag and Br, so it's just AgBr. And that's how that goes. Okay, so those were important examples, and they have a whole mix of different kinds of things. Here, this is just an atom and an atom, an atom and an atom. This is an atom and a polyatomic anion. This is a transition metal and an atom. And these are two, well, this is actually a transition metal, but without a Roman numeral, and just an atom that becomes an ion. So there were different combinations and possibilities for those different sorts of ones. If you have questions about any of them, or you think any of them are wrong, I might have made a mistake. I probably didn't. I don't know, I'm a big nerd like that. I just kind of do them. Put it in the chat or turn on your mic and ask. So what kind of questions do you have about naming or writing formulas for any of those? Nothing. Okay. We call that wait time. Waiting long enough for you to say something. Okay. Well, let me go back into the log back in. So I'll just show you what else you should practice. On Monday, we're going to deal with some things with compounds called hydrates, and those hydrates have another naming scheme. But in the end of the chapter, or in the end of the current week folder, you'll find this document says Naming Review 4, and it has ionic compounds that are a whole mix of things where you can write the names for them. And then down at the bottom, there's a whole bunch where you can write formulas. So I know that you could just Google these. The point isn't to just like Google them and know the name. The point is that you have to be able to take the periodic table and an ion chart and correctly write names and formulas. For the remainder of the course, you're going to be seeing names and formulas for compounds. Hold on, let me share that screen. All right, here we go. So the naming review 4, there are some compound formulas to write names for, and there are some compound names to write formulas for. So anyways, as I was saying, like I know that you're remote and you could just Google them and whatever, but to know chemistry and to be able to do it, and for the remainder of the course, you've got to be able to get these names and formulas matched up so that they make sense together. There's a reason why we always use formulas. Formulas are a much faster way to write the compound, and it shows you within the compound's formula how many of each atom are present. And by looking at the formula, it's a whole lot easier to do a lot of the mathematics and what we call stoichiometry. But then elements have names, and in prose, in writing, we write the names of the compounds. And oftentimes they go together and they're included in both things. When we buy bottles of chemicals, the bottles of the chemicals tell you a bunch of different things. They tell you the name and they also tell you the formula so that they match up together. But it's very important to be able to get those two things matched up. All right, so that's what I have for you today. You can use the rest of the time to practice these, and once you're able to do them quickly and you get the hang of it, then you're good to go. Now that we know that we're going to be remote for quite a few weeks, let's see, like there's next week, the week after that, the week after that, the week after that. So we've got 4 weeks. 2 of them are partial weeks and 2 of them are full weeks. Because we know that we're remote, me and the other chemistry teachers were working to put a plan together for how we're best able to do remote and come up with like assessments, and we'll put those online and we'll talk to you about that like on Monday and Tuesday, so you have an idea as to what we're going to be doing like next week, the week right before Christmas, and then a couple days before Christmas, and then what we'll do the 2 weeks after we come back from winter break. All right, if you don't have any questions or don't need any help with anything, you can leave the Zoom, and we'll see you here on Monday, like 8:30. If you have any questions, you can put them in the chat. You can turn on your mic. I'll answer any questions you have about anything with chemistry or anything with any science or any coronavirus issues or whatever you got. Otherwise, I'll see you guys on Monday. Have a wonderful, safe weekend. Stay away from people. They smell anyway.